Today we're going to be talking about quadratic equations and their graphs, which are called parabolas. Now in your notes there's a list of vocabulary words. They're out there. I'll go over them quickly with you. The first one, quadratic function. That's something in this form. Okay, an equation that starts with an x squared must include the x squared in this form. A times x squared plus b times x plus c. A parabola is what we call the picture of a graph, of a quadratic graph. And it's going to take the shape of a U or an upside down U every single time. You're going to see that it's going to go up forever or go down forever. We're also going to have to know what the vertex is. The vertex is either the maximum point or the minimum point on a graph. So we can easily identify it. This is the most important point because this identifies where the axis of symmetry is. Now the axis of symmetry is a vertical line to the parabola that divides the graph into two mirror images. And it's identified as a line as x equals some number. So the axis of symmetry is a vertical line going right through this point here. What this does is it splits it in half. Kind of like when we made hearts when we were little kids in elementary school for Valentine's Day. Kind of folded the paper in half, cut around the heart, and we had a symmetric heart. This does the same thing. So anywhere going horizontally, if you notice, like I picked these 2 points right here. It's two units going to the left, 2 units going to the right. If we go up a little more, it's 4 units to the right, 4 units to the left. If we go up a little bit higher, maybe about here, it's 5 to the left, 5 to the right. That designates the symmetry. And again, to sum up, a symmetry is having equal proportions from the axes, or equal portions from the axis, the same distance horizontally. So the main thing we're going to focus on to start off before we start graphing these is finding the vertex, identifying what our axis of symmetry is. We're also going to talk about the y-intercept. The y-intercept is right here where it crosses the y-axis. In this form, this c value is our y-intercept. So you might want to copy this little scenario down so you know that the vertex is the maximum or minimum point. The axis of symmetry goes right through the vertex in a vertical line. And we need to find the y-intercept is our c value. All these are important things when we start graphing or looking at quadratic functions. One of the great qualities about these quadratic functions is they are symmetric. If you notice, they're kind of similar to absolute value functions that we graphed earlier in the year. We have a vertex and it's going up at this. The only difference is an absolute value function made of v and the growth rate was constant. Here the growth rate constantly changes. It's going to be going different at each different point on the graph. And that's something we'll talk a little bit more about later in the year. The other thing to know is the domain. Okay, remember, domain is all our x values. The domain for quadratic equations is all real numbers. So no matter what number you pick for x going left and right, it will work. Whether it's a decimal, fraction, positive number, negative number, radical, any number you can think of, it will work. So that's some of the basics about parabolas and quadratics. Now we're going to start again by focusing on finding the vertex. So looking at this, if we're given a graph, it's where the two images meet, right on the reflection point. So if we're looking at this and we're given a graph, we simply identify what this point is. We can identify it as 1, 2, going over 4 and down 1. So the vertex in this is 4, 1. I'm going to designate the vertex just by a Vx. And we can identify our y-intercept right here. 1, 2, 3, 4, 5, 6, 7. So our y-intercept, again this is at 7, would be as a point 0, comma 7. Some mathematicians and some teachers are going to want you to identify this as a point as 0, comma 7. It will always be 0, comma number. Or you can say the y-intercept is 7, depending on how strict your teacher is. So from a graph, again, you're looking at the maximum point or the minimum point. In this case, this is a minimum. Okay, it's not going to go any lower than this, so this would be a minimum point. So the other way we can identify a graph, or identify a vertex, is if we're given a chart. Now, remember, if we're going left to right, our y values will continue to be going down. If you notice, it's at 7, here it's at 5, here it's at 1, and it goes down all the way to where it's, ooh, my vertex, I marked it wrong. My vertex is for -1. Ooh, screwed up there. So it goes all the way down to -1. Then what happens? As we get bigger, it gets back up to 0, up to 1, up to 7, and it keeps growing. So you're going to see where it comes down, comes lower, 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 and then starts going up. The point that we see when it starts to change is where we find our vertex at. Or if it's going the other way, it'd be going up and then coming down. So the change in the direction of our y values. So this is what it looked. Here's some examples. So here's the first one. Here's an XY chart. If you notice, all the x values are going up by 2's. It goes from -2 to 0 to 2 to 4, blah, blah, blah. We have these other points here for our y's. Now, if we look at this, we know our x values are not constantly increasing. It's going left to right. Our y values, though, going from 8 to 3, we're going down 5. From 3 to 0, -3. From 0 to -1, down 1. But now, all of a sudden, we go from -1 to +1. We're increasing by 1, and increasing by 3, and increasing by 5. So where does this change go? Negative, 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 then positive. Right in here. So I'm going to identify this and box this in. Again, this is our most important point. It is our vertex for -1. Now remember we talked about symmetry. Look at these numbers here. If we're moving up by 2's each way, look at this. These numbers are identical, 0 and 0. These numbers here, 3 and 3. Here we have 8 and 8. That's where our symmetry comes into play. Kind of like when I mentioned it up here in this graph here. Here it's it was 0, 7. Over here it's 8, 7. Our y values are the same. Now here's one that's going to have a, so this is going to be a minimum point because it goes down and then it's going to come up. Here's going to be the opposite way. If you notice our x values here, they're only increasing by 1 each time. But our y values from -4 to 5, it's increasing. From 5 to 8, it's increasing. But going from 8 to 5, it's now decreasing and decreasing and decreasing and decreasing. So as it's increasing, all of a sudden, right here, it starts to change. And again, here's our vertex at 0, 8. And again, you can see the symmetric points, 5 and 5, -4, -4, and so forth. And if we kept going this way, we would see at -3, it'd be -19. At -4, it would be -40. We can kind of keep going from there. Now the last one. This is going up by 0.5s. Again, the decimals don't matter, except we recognize that these are going up at an equal amount, all 0.5. This is going negative, 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 negative. Now it bottoms out at 0.75, then it starts increasing again. So it's going down, 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 negative growth, and then it's positive again. So right where it changes would be our vertex. 2.5 and 0.75 is our vertex. So we find our vertex in where it changes direction with our y values. And that's how we can find the vertex given an xy chart. Now the last thing we're going to look at is trying to find our vertex and our axis of symmetry and all the good stuff at our y-intercept given an equation. This is where it gets where we have to actually do some calculations. Erase the board. Too well. Okay. Now, when we're given these, we're going to start with the function. First one we had was f of x equals x squared plus 4x minus 5. Now, you're probably saying, how do we find our vertex with this? We have to use a formula right there. Negative b over 2a. We're going to be talking about this for the next several months. Negative b over 2a. It's going to be ingrained into your memories. Now, looking at this, we have to identify our a, b, and c values first. Remember, it's a times x squared plus b times x, and then minus c, or plus c. So our a value here is 1. Our b value is 4. Our c value is negative 5. So we have to plug these numbers in to this equation to get the first part of our vertex. This part right here. So this negative b means the opposite b value. So the opposite of 4 is negative 4. And then we go 2 times our a value, which is 1. So we end up with negative 4 over 2, and that reduces down to a plain old negative 2. This is the x value of our vertex. That's what goes there. To get the y value, this is where we plug this in to our equation up here. So we have negative 2 squared. Make sure if you're using a calculator to put it in parentheses. Plus 4 times negative 2 minus 5. Negative 2 squared is 4. 4 times negative 2 is minus 8. And then minus 5. This ends up being negative 9. There's our vertex. Use the negative b over 2a to get the x value. Plug that x into here to get the y value. Now the axis of symmetry is easy right now. It's this value right here. The axis of symmetry is just x equals negative 2. I'm getting that value from this point right here. Once I get my vertex, I know that line's going right through that x value. And then finally, the y-intercept. Remember, our y-intercept from that first couple minutes of the lesson is our c value. Right there. So our y-intercept is negative 5. Or as a point 0, negative 5. So again, from our y-intercept, we don't have to do any work. Now the other problems we will go over in class and kind of work through them together. See you next time.